So on number 1, problem number 1, our base is the same. Yes. We want to get our bases the same in all of this, and they are the same. So anybody have any idea what we could do to solve that? Since the bases are the same, can we find out what x is?
Yeah. You gotta make it the same.
That's right. So good, good. Aiden, so then it would just, we can take those bases away if they're the same, and then we can set the exponents equal to each other. So x is equal to 3. Does that make sense?
Yeah.
Okay. So on number 2, are the bases the same?
No. No, because you could divide by them.
Are the bases the same on number 2?
Yes.
Yes. So we can take those bases away. Negative p minus 3 equals negative 3p. Is there somebody that disagrees that the bases were the same there?
I disagree.
You disagree?
Yeah.
The base is a 4 and a 4.
It's all about the base. P minus 3, and that's
not the base.
That's not the base. Oh, it's just the, oh, it's all about. Oh,
wait. About the base. He has a point. That's not you.
oh my.
Oh, Chelsea got a point though. No, because negative times of negative are positive. Negative is all about the base.
What is the base on this here? 4. What's the base here?
You're the same.
No, 4 again. The bases are the
funny.
same. Okay, thank you those of you who are sitting quietly.
I'm saying put in that.
We can take the bases away and set the exponents equal to one another. That's all we did.
So that makes sense, but that's not math.
So now, absolutely it is mathematical. I know it's a weird, something you haven't seen before, but it's kind of a cool thing if you're a math nerd, you know. So now, what would we do to solve this? Because we. So, add p to both sides?
Oh,
Hold on a second. Raise your hand, please. Thank you for raising your hand.
yeah.
So we get negative 3 equals negative 2p. And then, Will, what would we do next?
You add the 3. Or no, you could divide by 2 as well.
Divide by, what do we want?
Negative 2.
Good, negative 2. So then we get p equals positive 3 over 2. So we get our bases the same. It's all about the base today. So back to that song, though. I do like that song, and that I think it's a good message.
Yeah,
Worry about what's inside. Yeah, don't worry. Somebody wants to look somewhere else and doesn't like something about you. Anyway, sorry. So number 3. Are my bases the same in number 3?
No.
I need to get your attention back up here, please. Are the bases the same in number 3? No, we need to get those bases. We need to get those bases to be the same. So I'm going to look at the smaller number, 7. I want to see, can I take 7 to some exponent to get 343? Please use a calculator. Get one if you need to. Don't say it aloud. Raise your hand if you get it. 7 to what exponent gives you 343? You're literally going to guess and check on the calculator. Raise your hand, please.
49.
Raise your hand, please.
Also, raise your hand.
It's an exponent. 7 to what exponent? Not 7 times what, it's 7 to what exponent gives you 343?
747.
Please raise your hand. Did you get it?
Oh, yeah.
What is it? It's 3. So 7 to the negative 3r plus 1 equals 7 to the 3rd. So we have our bases the same. We can now take them away and set our exponents equal to each other. So negative 3r plus 1 equals 3. So this group here, tell me what I do next to solve for r.
Wait, I'm like getting confused with what we're looking at. Oh, -1.
Okay.
-1.
Did you have a question on what we did so far?
No, I
Okay.
thought you were like 6.5, and like 3R plus. I was like,
So we get a negative 3R equals 2. And this group, what do we do next? Sunny answered that one, so if somebody else wants to answer it. Yeah, divide by negative 3. And we get R equals negative 2/3. Okay, number 4, are those bases the same?
No.
They're not. So we want to look at which base? The 6, the smaller one. Check 6 to what exponent gives you 216? Please don't say it out loud. Use your calculator. You're literally doing guess and checks.
6 to the 3rd. Ready? Yeah. I can't contain myself when I see a math.
I believe in you.
Sorry, I'm talking about that.
So, 6 to what exponent? This is 216.
Is it 6 to the 3rd?
Yes, it is. So we write 6 to the 3rd equals 6 to the negative 7v. So this same group, tell me what to do next.
Oh. Divide by 6 on both sides.
Not yet.
No. Turn this 3 equals negative 7b, right?
Yes.
What's that process called?
We're just setting our exponents equal to each other because those bases are the same. Only because of that.
I understand.
And then somebody else decides what's the next step. Good. Divide by negative 7. And b is equal to negative 3/7. Okay, I'm going to give you a different problem to do than this one. This one is a little bit tricky. So I'm going to change this. So solve this one. Do this as an try. You can do it on your table if you want, or you can do it on your paper, whatever you want, on your whiteboard or on your paper. So number 5, I changed it though. It's a little bit different. The one that was there was a little bit too hard. Yeah. Use the rest of somebody else.
Thank you.
Oh.
I'm the over. I'm over on 5 minutes. I'm turning it off with what is this? Because this is
no, it actually no. Paper actually lasts longer. The paper actually lasts longer. It actually does.
What does it last long?
It lasts longer than a regular.
How do you?
Yes, it does. Yes, it's big.
I see
Things last longer.
No, they don't. No, they
Yes, they do. Well, I mean, if you don't have a higher quality,
I had my
they usually last me
I was like 0 last week.
so it's fine.
So 3R plus 2 plus 2, right?
Yeah, so
I get it now. I get it now. I get it now. I saw. No. I know they'll have like a blank.
Okay, so you should have gotten 4/3 for your answer on that one. Questions on that before we move on? I'm gonna go harder. As you may have noticed my pattern, I start easier and then get harder. Okay. So, attention back up here, please. Do we have a number? Can we, like, if we look at the smaller one, 16, if we take 16 and square it, what does that give us? 16 squared. What does that give
there's not
us?
even a 7. Oh, shit.
256, too big. So this time, anybody have an idea what we might do on this one? It's pretty dividing because we've got some exponent there. We're going to have to go lower. So we're, rather than using a 16 or a 64, what's something, what it might be another base I could use? 4, yes. Because 4 to some exponent gives us 16, right? 4 squared. And then 4 to what exponent gives you 64? 4 to what exponent gives you 64? 4 to the 3. We have to have the numbers be the same, so they both have to be 4. Since we chose 4 here, it has to be a 4 here. And we couldn't do 8 to some exponent. You're right. You're right. You're right. 8 squared would give you 64. The problem is 8 to some exponent doesn't give me 16. So then what do we do with the 3 and the negative 3k? We're going to multiply because it's 3 next to that negative 3k. Sorry, let me write it again. Negative 3k. So when we have an exponent to an exponent, remember we multiply. So we're going to multiply those. 3 times negative 3k is?
Negative 9k.
Negative 9k equals 2. So we take our bases away. And then back there, this group back here, what's the next thing that I do?
Divide by 9? We divide by 9, negative 9.
Divide by negative 9 is correct. So we have k equals negative 2 ninths.
Wait, what?
Yeah, I got 11.
Wait, what?
Because how do we get 2? 4 squared is 16. I have to change both the bases. I can't just change one of them. They have to be the same. Okay, guys? So what would be my common base on 7? Because the bases are not the same. 25 squared gives me something larger than 125. So I have to change both my bases again.
Well, it's going to be more complicated.
That's right. It's get a little more complicated. So can I get a hand, please, for what my bases might be? Sunny?
5.
Yes. So 5 to what exponent is 25?
2.
2. So what are we going to do with the 2 and the 3m? Multiply. Because an exponent to an exponent means we're multiplying. So 5 to what exponent is 125? That was a little harder. Preston, you got it? To the 3rd. We have a lot of 3's here. It's just a coincidence. It's not always going to be 3. And then what do we do with the 3 and the negative 2m minus 2? Multiply again. So I'm going to change this too. So it's taking the bases away. Actually, this group, this group here, tell me what I do next.
Multiply the 2 or 3m and 3 that's
So 2 times 3m would be, and what do I do with 6m? Yes, so I'm going to take 6m and set it equal to, if you wanted to multiply this all at once, that's fine. I'm just going to write it out in case someone might be confused. So when I go ahead and distribute it for me here, what do I get?
6m minus 6.
Good. Thank you, those of you who are being polite, which is most of you. So now, what do I do next to solve for m?
Would it be -2?
Sorry, this was a -2. I'm a copier. Good catch, Aiden. So this should be a -6m minus 6. And then what would be my next step here in this group? That's right, add 6m. So I get 12m equals -6. Last step. Yeah. And what does m equal? -1/2. Okay. So. So I've got a fraction here. I want to change that fraction. Can I make this fraction equal to 3 to some exponent? 3 to what exponent would be 1/3? Negative what? No. It's a negative, but -1. So 3 to the -1, because remember this is a 1 here. So this is like 3 to the -1. And then 3 to what exponent is 27? Just go back here.
This one right here. That is 3.
Is 3, yeah? So same group, what do I do with the 3 and the -2n? Why are you guys?
Oh, that's all for our group.
Here.
That's for our group. Oh, well. Oh. You already said it.
What do I do with the 3 and the -2n? Multiply, that's right, because I have an exponent to an exponent. Okay, so now I need to do what? This same group back there. What do I do? Yeah, so what do we get? And what do I do with -6n?
Wouldn't you divide it then?
No, we got our bases the same. Once we have that, what can we do with those bases?
Like -1, which is add 1.
Not yet. We got to get an equation.
That'd be add 1, right?
So what do we do with the 3?
No, you already got the same basis.
We got the bases. What do we do with those exponents? What's the basis?
Multiply the exponents though?
What's that?
Once you multiply the.
Not yet. I mean, if you want to, you can simplify that. But what? Yeah, I want to do something with those bases. Can I take them away?
Yeah,
Yes.
take them
When I
away.
take them away, what do I get? No.
Wait a second.
When I take the bases away, what do I get? So you don't have to tell me the answer. Just tell me. So you can take the exponent, which is 3 times -2n, and set it equal to -1. So some of you might have gone right away and multiplied that. Does that make sense?
Yeah.
Okay. So now, all I did is I took the bases away, set the exponents equal to each other. So I have -6n equals -1. Last question, same group back there. Just one second.
Divide by -6.
Divide by -6. So n equals 1/6. Tristan, what's your question?
Why aren't the exponent
No, the exponent stays the same.
How does the exponent become a base? It's not a base, it's just we take the bases away. We just cross them out. And since they're equal, I can set my exponents equal to one another. Only if they're equal though. Only if their bases are equal can I do that. Okay, number 9. So this done this one a lot. Is there some way? Normally I go to the smaller one and make the other one that same. This is the only time I'm actually going to get bigger. I'm going to say 2 to what exponent will give me 1? A hand, please. 0. Good. So 2 to the 0 equals 2 to the n minus 2. 2 to the 0 is 1. I know it's weird. Okay. So now, what do we do next? Same group. Oh, no, I already asked you. Tell me in this group. What do I do next? Yep. And so what do I set equals to what? Equals? Yes, equals 0. So I add 2. And n is equal to 2. So I'm going to stop here.